Okay, this video is going to be a review for over Unit 6, which is what our third 9 weeks exam is going to be on. Now, if you would like, you can write down this review, or you can just pay attention. I know that our problems have kind of been spread out, what we've covered in this unit. So that's why I want to do this video, to make sure you understand what's going to be on our third 9 weeks exam. Now, it's mostly going to cover moles and the types of problems that we're going to work is molar mass, percent composition, and mole conversions, which are moles to grams conversions, and then back, grams to moles. So that's the three major types of problems that we've covered, and then there'll be a few other questions regarding moles and things that we covered in this unit. So first, we need to talk about moles and what they are. So moles are the SI base unit, measuring the amount of a substance. Or the number of particles. There's a couple of different ways that we can define a mole. One way is in terms of particles. When we define a mole in terms of particles, we're talking about atoms. If we're talking about an individual element, if we're talking about a covalent compound, we call that molecules. And if we're talking about ionic compound, we call it formula units. But all of those things together are just particles. And 1 mole is equal to this number. This big number here, 6.02 times 10 to the 23rd particles. So 1 mole of anything, if we have 1 mole of sodium, it's equal to 6.02 times 10 to the 23rd atoms of sodium. If we're talking about carbon dioxide, a covalent compound, CO2, it's a compound that 1 mole of it would equal 6.02 times 10 to the 23rd. We're talking about NaCl, sodium chloride, it would be 1 mole of it would be equal to 6.02 times 10 to the 23rd formula units, or particles. Now this number is important in a way, but we don't deal with things in individual particles because we can't count things that we can't see. It's kind of like when you go to the store and buy some bananas, you don't buy them by 1 banana, you buy them by, the pound. So there's an easier way of measuring out things than in terms of particles. But that number is important because it bridges the gap. A mole, if we're talking about particles or numbers of molecules, moles bridge the gap between particles, counting them out, and grams. Now, moles we cannot weigh out on an electron balance because 1 mole of each substance is different. A mole of carbon dioxide weighs a different amount than a mole of sodium chloride. So we have to weigh things out in terms of grams. That's why we have to convert from moles to grams. But moles is kind of a way of making things easier for us when we weigh something out. And we'll be talking about in the next unit the importance of the mole in a balanced equation that allows us to do some calculations. Now, this 6.02 times 10 to the 23rd, The man that came up with that his last name was Avogadro. So we call this Avogadro's number. All right, so next thing we want to talk about, and a mole, another way we can define a mole is in terms of molar mass. Because when we have molar mass, the definition of that is the mass of 1 mole of a substance, an element or a compound. So it's going to be important that we talk about atomic masses. If we look at a periodic table, if I have, carbon, if I look at it, the atomic masses are the masses that are the decimals. It's not the top number above the symbol. If I look at carbon, see there, it is the bottom number, 12.011. We're going to round these 2 decimal places. On your periodic table, they should already be rounded 2 decimal places. So all of our answers are going to have 2 decimal places. And so it would be 12.01. So 1 mole of carbon weighs 12.01 grams per mole. 1 mole of lithium weighs 6.94 grams per mole. Actually, if you talk about lithium atoms, it's really 6.94 atomic mass units. But to make things easier, we just say grams. 1 mole of sodium would weigh 22.99 moles. If we're talking about a compound, we have to add up the individual masses. Like if we have HCl, H is 1.01 grams per mole. Cl is 35.45 grams per mole. We would add those together to get HCl to get its molar mass. But these atomic masses we can also call molar masses. If we're usually talking about 1 atom, we call it 1 element, we call it atomic mass. If we talk about a compound, we call it molar mass. But to make things easier, I always use the term molar mass. Now, the units for molar mass, and this will be a test question, is grams per mole. Because 1 mole of something is equal to its, grams. And each substance, if we're talking about particles, 1 mole is 6.02 times 10 to the 23rd for everything. But if we're talking about the molar mass of a compound, 1 mole is equal to its molar mass, and it's different for every element in every compound. All right, something else we're going to talk about is percent composition. Now, why do we find the percent composition? Well, it's easy. If we have an unknown compound, we can figure out its percent composition of each element in the compound, and then that'll allow us to come up with the formula for the compound and identify it. It's also used in talking about how polluted the air is, the percent composition of the elements in the ground, in the soil. So it has its uses. But percent composition is defined as the percent by mass of each element in a compound. So all these definitions will be on our test. There will be test questions. Now, I usually abbreviate mole. I don't even know why it's an abbreviation, but it's just MOL. So if you see that, don't think I've misspelled it. It's just the way of abbreviating mole by just leaving the E off. So we look at the example problem. Say we want to find the molar mass of MgOH2. To find the molar mass, we add up the individual atomic masses. So if we look at magnesium, we have 1 atom of magnesium there. We're going to multiply it by its atomic mass. If I looked on the periodic table and I look below the symbol for magnesium, I see that its atomic mass, rounded to 2 decimal places, is 24.31. There's one atom of it. I'm going to multiply it by its atomic mass. Oxygen, if I look in the parentheses, I have 1 on the outside, inside. I multiply that by the number on the outside. And remember, the number on the outside of the parentheses goes with everything just on the inside of the parentheses. So for oxygen, there's 1 on the inside times 2 to give me a total of 2. Oxygen's atomic mass is 16.00. Hydrogen, I have 1 on the inside times 2. So hydrogen, I have 2 of those times its molar mass, which would be 1.01. And I'm going to do the math for that. 1 times 24.31 is 24.31. 2 times, for oxygen, 2 times 16 would be 32.00. And then hydrogen, 2 times 1.01 is 2.02. And then if I add up the individual masses to give me, that would be 3, 6, 8, 58.33, and then my units would be grams per mole. So that's how you find molar mass. They're all work the same exact way. Now to find percent composition, my steps for doing that is to first find my molar mass. I've done that for magnesium hydroxide. Now I want to find the percent composition of each element in this compound. Alright, so I'm going to take each individual atomic mass divided by the total. Remember, for percent composition, you take the part divided by the whole times 100 to get a percent. So I found my molar mass. Now I'm going to take each individual mass divided by the total, multiply by 100. So for magnesium, its mass was 24.31. I'm going to divide it by the total, which is the molar mass, which is 58.33, times 100 to get a percent. For oxygen, that would be 32.00 divided by the total, 58.33, times 100 to get a percent. And then last, hydrogen, its mass, and this was 2.02, divided by the total, 58.33, times 100 to get a percent. So I'm going to get my calculator. And for magnesium, it's 24.31 divided by the molar mass, which is 58.33. And that gives me 0.416, but I'm going to multiply that by 100 to get a percent. I'm going to round this to 2 decimal places. So for magnesium, that would be 41.676, which would be 41.68%, and that's magnesium. For oxygen, it would be 32.00 divided by the molar mass, which is 58.33, times 100. That gives me 54.86% oxygen. And last, hydrogen would be 2.02 divided by 58.33. and then multiply it by 100 to get a percent, and I get 3.46%. And that's hydrogen. Now, on the test, the questions will be asked you just for the percent of one of these elements, but I would suggest you do it, find the total percentage for all the elements. That way, when you add them up, you can check your answer. The answer should be 100 or very close, like 99.5 to 100.5. Somewhere really close to 100, you can check your answer by adding them up. So if I take 41.68 plus 54.86 plus 3.46, I get exactly 100. So more than likely, I got this answer right with all these. So this magnesium hydroxide is made up of 41.68% magnesium, 54.86% oxygen, and 3.46% hydrogen. Now, the only other type of problem we have is converting moles to grams and grams to moles. And I'm going to use the same compound here, magnesium hydroxide. And if we have an example like this one, how many grams is 3.3 moles of magnesium hydroxide? So when I'm converting moles to grams, going moles to grams, I need to remember, I need to either set up a conversion factor, which is 1 mole is equal to the molar mass of it, or I can simply remember when I'm going moles to grams to multiply by the molar mass. Now I figured that most of you, if not all, are simply going to multiply by the molar mass instead of setting up a conversion factor and canceling out your units. So that's the way I'm going to work these. Remember moles to grams. If you remember going moles like mini, grams is grande, mini to grande. How do you get from small to big? You have to multiply. So I take in my molar mass, magnesium hydroxide, I found out in the last problem, I'm just going to use that already calculated. You need to calculate the molar mass, but I already did that in the last problem, and it was, if I look back, 58.33 grams per mole. Now I'm simply going to multiply my moles by that. So I'll take 3.3 times 58.33. My answer is 192.489, which 2 decimal places. If I round that, my answer is going to be 192.49, and that will be grams of MgOH2. So always remember, moles to grams, you're going to multiply by the molar mass. And the problems, you'll have to calculate the molar mass first when doing these problems. Now to look at one last one, I'm going to use the same compound, magnesium hydroxide, and we'll ask how many moles is 872 grams of MgOH2. Now in this problem, when we're going in this case, we're going grams to moles. We're going to take our grams given in the problem and we divide that by the molar mass. So you should put the mass that's given in the problem first, which will be 872, and divide that by the molar mass of MgOH2 instead of the other way around. Do not put the molar mass first into your calculator. Put the grams given in the problem, otherwise you will miss it. Alright, so I figured out in the last problem that the molar mass I calculated to be MgOH2 is equal to 58.33 grams per mole. So in the problem, I take my grams given, which was 872, divided by the molar mass, which is 58.33. When I calculate it, I need to round my answer to 2 decimal places. 14.949 would round to 14.95. My units will be moles of MgOH2. So, to review over this real quick, there'll be 3 types of problems on the test. We'll be calculating molar mass, find the percent composition of each element in a compound, and then converting moles to grams and grams to moles. When I'm going moles to grams, I am multiplying by the molar mass. When I'm going grams to moles, I am taking the grams given in the problem and dividing it by the molar mass to get that answer. Also, we said that the mole is the SI base unit for the amount of a substance or the number of particles. 1 mole is equal to 6.02 times 10 to the 23rd particles. And 6.02 times 10 to the 23rd is called Avogadro's number. Molar mass, the mass of 1 mole of a substance. It is different for each element and each compound. And its units are grams per mole, and percent composition is the percent by mass of each element in the compound. To find that, we first find the molar mass, and then we take the individual masses divided by the molar mass and multiply it by 100 to get the percent. So the first step in all these types of problems is to find the molar mass and then use it to solve for whatever the problem's asking for. Okay, your assignment now is to complete the study guide. Make sure you do that, and you should be fine for this test.